Welcome to Chillin' 101. We hope this video helps.
You begin by checking prerequisites and taking immediate action. Install Python 3, 8+, PyTorch or TensorFlow, and OpenCV. Next, collect 200-500 representative images and annotate them with bounding boxes. This gives you rapid feedback. Choose a pre-trained backbone such as ResNet or MobileNet to avoid training from scratch and set up a minimal training script. Once done, run one short training pass to verify data loading, augmentation, and that losses decrease. This confirms the pipeline works. You now focus on the middle, more complex steps, training and validation. Split your dataset 80/20 and ensure each class appears in both sets. Imbalance skews metrics. Use augmentation, flip, scale, color jitter, and mosaic to build robustness. Start with a conservative learning rate and small batch size, then run experiments while tracking MAP and loss curves. Make sure to use transfer learning, checkpoint frequently, and enable early stopping. Once you see consistent MAP improvements, schedule longer runs for final tuning. You finish by preparing the model for real use in planning iterations. Export to ONGs or TensorRT for deployment, and consider quantization to reduce size and latency. Test end-to-end on your target device, measuring inference time, memory, and precision, then adjust model scale versus speed. If results fall short, troubleshoot, verify label consistency, correct class indices, and that anchors and input sizes match training. Finally, iterate on data, augmentation, and hyperparameters until accuracy and latency.
Thanks for watching. Consider subscribing if we helped you.